Hi everybody, welcome back. Today I wanted to take some time and go over one of our in-class participation activities. This is the one that we were working on in class together on September 19th, which was last week. And this was right after we wrapped up our chapters on market welfare, taxes, and price control. So price ceilings, price floors, whether they're binding or not. And so this is just a review of that. And we didn't have time to go over the whole thing in class. And I think it's a great opportunity to just review this stuff and make sure it's really solid, because it's a great way to review the market forces of supply and demand. It's also a really great way to just get a reminder of how all these things integrate with each other. There's a little bit of an element of elasticities in here. And so there's also some nice questions about sort of what the goals of policies like price controls and taxes are. So I'm going to go ahead and go through it. I'm going to use all of my most colorful pens to try and illustrate this in a fun way. And we'll also be calculating welfare mathematically. So I've got my little calculator here. We'll be using the formula for the area of a triangle and a rectangle to do that. So hopefully you've got that in mind. If not, we'll do a little quick review of it and look at that total welfare, the consumer surplus and producer surplus, look at the effects of a tax, measure the deadweight loss, and then talk about the effectiveness of taxes, the goals of taxes, and talk a little bit about price controls. And in this case, we'll be looking at the example of a price ceiling and the price of gasoline. So I'm going to go ahead, and because this is on our beautiful little graph paper here, I'm not going to use the whiteboard. I'm going to use the the document camera, so you can see the actual form. It doesn't mean you can't study from this example if you don't have the assignment, because the intuition is still going to be totally valid, even if you're using different numbers and different equations. The idea of how we calculate consumer surplus, producer surplus, and all those things, the idea of where they come from, the idea of price controls, those are universal. And this is just an example to help you understand that. So let's get started. We're looking at the graph for the market for hotel rooms. We've got the market for hotel rooms here. And we want to always start out by identifying our equilibrium price and equilibrium quantity. Remember that we have our upward sloping supply curve, downward sloping demand curve in price and quantity space. And so our equilibrium price is going to be right here at $100 and 100 hotel rooms. So before the tax, I'm going to just write this out. We have a price of $100 and a quantity in equilibrium of 100 hotel rooms. And that's just nice to have as a starting point so we know where we're going with this. Then we want to go ahead and start off by calculating the consumer surplus and producer surplus in the market in equilibrium now. And then after we calculate consumer surplus and producer surplus, we'll go ahead and look at it after the tax is imposed. So I'm going to do it a couple of different ways. The first thing I'm going to do is I want to identify consumer surplus. And we want to remember that consumer surplus is always going to be willingness to pay minus price, which in this case, willingness to pay is given by this demand curve, right? The demand curve represents the marginal consumer's willingness to pay. And then the price they pay is given by the market. So the idea here is there's this triangle that represents all these different people's willingness to pay. Some people would pay, we're going to go ahead and assume that that is $125 for a hotel room. Some people would be willing to pay $115 for a hotel room, $110, maybe $105, even $100. And then there are these people down here who would want to pay less, maybe only $90 for a hotel room. They don't enter the market because this equilibrium price is too high. But everybody here in this teal triangle is in the market buying a hotel room and paying $100 of it regardless of their willingness to pay. So in order to find the value of consumer surplus, we want to find the area of this triangle. And we remember that the area of a triangle is given by 1/2 base times height. The base of the triangle goes from 0 to 100 hotel rooms. So we'll go a base of 100 and a height from $100 to $125. So 125 minus 100 is going to give us a triangle with a height of $25. One half of 100 times 25 is going to give us one half of $2,500, or a total consumer surplus of $1,250. So that's our consumer surplus in equilibrium before we impose a tax. Producer surplus is going to be really similar. It's the producer side of things, and it's going to be price minus willingness to sell. And that comes from the idea that this supply curve contains every marginal producer, and they all face different costs based on their technology, their ability to produce, whatever. And so the firms that produce at the lowest cost enter the market first. Some firms can produce a hotel room of equal quality at $50. Some do it at $70. Some do it at $80. Some do it at $90. Some do it at $100. The less the cost of production for the firm, the greater the difference between the price they accept because of the market and the lowest price they were willing to accept based on whatever their technology is. There are firms up here who could produce a hotel room for $120, but they don't enter the market because they're just not as efficient, right? No one wants to pay, or very few people want to pay $120 for a hotel room. And so what we have is just the most efficient consumers entering the market, the most efficient producers entering the market first, and all of them charging that price. So we're going to find the area of that triangle, which is going to, again, be 1/2 base times height. The base of the triangle runs from 0 to 100 hotel rooms, so that's 100. And then the height of the triangle goes from $50 to $100. So that's going to be a height of $50. So now we just need to find 1/2 of $5,000, or in this case, we have a producer surplus of $2,500. And this is where we get the idea that markets are so good at producing these outcomes. We have the lowest cost producers entering the market first, and we have these consumers who value the hotel room the most entering the market first. If you don't value it very highly, you're not going to necessarily make it into the market because you're not willing to pay that price. And if you're not very efficient, if you're maybe not good at producing hotel rooms, you're not going to be priced into the market because your price is going to be higher than the total market value. When we put these together, we get a total surplus, and our total market surplus, or our total welfare. Either, you can use either term, it's totally fine with me. We can call it total welfare or total surplus. It's going to be consumer surplus plus producer surplus, which in this case is $1,250 plus $2,500 for a total value of $3,750. That's the total welfare to the market of participating in this economy. So that's pretty great. That means that everyone is benefiting from this market exchange, and that's a great idea. Now we're going to go ahead and levy a tax. We talked about this a little bit, but the idea here is that the government is going to impose these taxes in order to generate revenue. And in the next chapter, we'll talk about public goods and externalities and why the government might need revenue to provide some things that the market can't. So in this case, the government's going to impose a tax of $30 per hotel room on consumers. We want to find the new quantity, the new prices. The price buyers and sellers pay is going to be different. There's going to be a $30 gap in between the price they pay. So here, in the initial condition, both consumers and producers pay this $100 price. But when the government takes $30, that's going to mean that there's going to be a space in between the price buyers pay and the price sellers pay of $30. And that's where the tax is going to come from. And then we want to look at how consumer surplus, producer surplus, tax revenue, and deadweight loss have changed. So we can figure out, what we need to figure out first and foremost is, with the tax, what is the new quantity being exchanged? And so in order to do that, we can do it two different ways. The way most textbooks will tell you to do it is to say, okay, who is the tax imposed on? It's imposed on buyers, so it's going to be the demand curve. So we're going to try and lower this demand curve by the size of the tax by $30. So we go from 25 to 15 to 105 to 95. And that'll give us this sort of fake demand curve that considers the tax and gets us to the quantity we want. If that's confusing to you, and it's fair if it is, because it's not really a demand curve, another way to look at it is to say, okay, this is our equilibrium, and we need to reduce the quantity until we have $30 of space between the price consumers pay and the price producers get. And so if we do that, if we move out of the equilibrium, we can see here we have a space of about $15, and then we go to this next quantity of 80, and we have a space of $10, $20, $30 between the demand and supply curve. And that's actually the same quantity that this fake demand curve that I kind of drew right here is at. And so either way you do it, it's fine. But the idea is you want to get to this quantity because that's our new equilibrium quantity. And it's going to tell us the new price that our sellers get. Our sellers are going to be willing to accept $80 at a quantity of 80 hotel rooms. And our consumers are going to be willing to pay a price of $110 at that new quantity. So I'm going to draw this in purple to really make it pop. And this is going to be our tax. So with the tax, we are going to see that the new Q star, or the new equilibrium quantity with the tax, is going to be 80 hotel rooms. We're going to see the price that buyers pay in this new equilibrium is going to be this higher price of $110. And the price that sellers get when they rent these hotel rooms out is only going to be $80. And this makes sense if you double check, because the difference between 110 and 80 is $30. That's that size of the tax, $10, $20, $30. So this is going to be our tax revenue right here. And we can actually calculate this by finding the area of a rectangle, right? The value of the tax is going to be the area of this rectangle from 0 to 80 hotel rooms and from 80 to $110. Or you could think of it another way. You could say, hey, listen, the government imposes a $30 tax on each hotel rooms. $30 tax times 80 hotel rooms, that's going to give us a tax revenue of $2,400. And that's the same as the area of this tax revenue triangle or rectangle right here. Okay? So far, so good? So one of the big ideas here is that when we impose a tax, we put a wedge between buyers and sellers. We split buyers and sellers. We make both of them a little bit worse off. And the hope is that we do that for a good reason, because that tax revenue is then going to turn around and be used to do something important for society. So now we've identified the price buyers pay, the price sellers pay, and the new equilibrium quantity. We might want to talk about next the incidence of the tax. And remember, the incidence of the tax is who bears the burden, who pays the most. We already said that consumers are going to see their price go up from $100 to $110. So that's an increase of $10 in the face of this tax. But what about sellers? Sellers used to get $100 for every hotel room. Now they only get $80. That remaining difference of $20 is going to the government. So who's more harmed? Who's bearing the incidence of the tax? It's going to be the producers, right? They see their revenue go down by $20 a hotel room, and consumers only lose $10 a hotel room. So it's going to end up being that producers bear the incidence of the tax. Does that kind of make sense? And if we think about it, that might make sense from an elasticity perspective. If you think about hotel rooms, and we want to define the sort of relative elasticities, remembering that it doesn't matter who we impose the tax on. The idea that the taxes on buyers isn't who bears the incidence. The incidence comes down to who can more easily avoid the tax. And if we think about hotel rooms being a luxury good with a lot of substitutes, people could do lots of different things with their leisure expenditure other than going to a hotel, especially with modern things like Vrbo and Airbnb. Hotels might need to pay that tax just to get people to come to the hotel room. So it might make sense for producers to pay the bulk of the tax, pay $20 worth of the tax, while consumers only pay $10 of it. So now let's look at the effect on consumer surplus and producer surplus. So remembering that consumer surplus is the difference between willingness to pay and price, we're going to look at the space beneath the demand curve and above the new price consumers pay. We can already see this triangle went from being big to being smaller. We can calculate the area of the triangle in the same way, 1/2 base times height. Now the base is from 0 to 80 hotel rooms. And now the height is from $110 to $125. So it's only going to be a height of $15. And so 1/2 of 80 times 15 is going to give us an area of $600 for consumer surplus. Producers had a much bigger surplus before the tax, but we can already see how that triangle got smaller. It got smaller for two reasons, right? It got smaller because they're facing a lower price and because fewer hotel rooms are being bought and sold. So now the producer surplus, which is the willingness to sell, price minus willingness to sell, is going to be the area of that triangle below the price that sellers face and above the supply curve right there. And we can already see that's a smaller triangle. It's going to have a base from 0 to 80 hotel rooms. And it's going to have a height from $50 to $80. So that's only going to be $10, $20, $30 total. So 1/2 of 80 times 30 is going to give us a producer surplus of $1,200. So both of them saw their surplus go down, but we can see that producer surplus is less than half of what it used to be, and consumer surplus is also less than half of what it used to be. And it's going to be, again, for that same reason. There's economic activity that's not taking place over here, hotel rooms that would have gone from sellers to buyers if it wasn't for the tax, but it's also that everyone's facing different prices. So that gives us the producer surplus, the consumer surplus. We've got the tax revenue, and now we want to calculate the deadweight loss. And the deadweight loss is this area over here. It's the area of these 80 to 100, these 20 hotel rooms that are no longer being sold by producers or bought by consumers. It's going to be based on the size of the tax and the quantity of hotel rooms that don't get bought or sold anymore. So our dead weight loss is also a triangle, right? Which means we can use 1/2 base times height to solve for the area of the dead weight loss also. So the height of the triangle is going to be from 80 to 100, so that's 20 hotel rooms. And the base of the triangle is the size of the tax, from $80 to $110, or $30. 1/2 of 30 times 20 is going to give us a total deadweight loss of $300. And when we calculate total welfare, we want to include the tax revenue, include consumer surplus, include producer surplus. Those all go somewhere. They all benefit someone. Deadweight loss is the reduction in total surplus or total welfare from the tax. It's the effect the tax has on total welfare. Okay, does that make sense? Hopefully. If not, let me know what questions you have. The next question asks, do you consider this tax successful? And that's kind of a tricky question, but the answer here is going to depend on how you measure the success of the tax. If you want to raise revenue, well, it did that, right? It raised $2,400 in revenue. Was it efficient? Did it minimize deadweight loss? Well, relative to the revenue, it only created a small deadweight loss, but it did create some deadweight loss. Maybe there's another way you want to measure the efficiency or the success of the tax. Maybe you wanted to target hotel owners or hotel sellers. If you wanted to target them, then that's efficient. If you were trying instead to target consumers and say, hey, listen, let's get at some of this leisure expenditure that these people are using and spending and try and target and tax leisure, maybe it's a little bit less successful because we're actually having the incidents be borne by producers. So whether or not it's successful is going to depend on your goals. Does that make sense? So whatever the goals of the tax are, that's what you need to be assessing. So if I ask you this question on a homework or an exam, what I'm really asking you is, there's lots of goals to this of a tax. Is this a good tax and why? So think about what are some of the things you think about with the tax and whether you think that those goals are being met. Okay. Now let's move on to the price control problem. And for this, we're going to need to graph a market. We're going to be looking at the market for gasoline, and we're going to try to see the government solve the price with a price ceiling. And remember, the price ceiling is a limit on how high a price can go. And so this is trying to keep prices low. So let's graph our market in equilibrium. We start out with just a traditional gas market. And so I'm going to put the quantity down here on the y-axis, or on the x-axis, price up here on the y-axis. And then I'm going to go ahead and graph my demand curve in equilibrium. And maybe you want to have a steeper demand because we know that demand is pretty inelastic for gasoline, but that's not the most important thing here. And some supply curve. And then I've given you an equilibrium price of $4.94 and an equilibrium quantity of 13,600 gallons of gas. And so that's our market for gasoline in equilibrium. So that's part A. Part B says, okay, what if the government imposes a price ceiling of $5? What will happen to the market? So let's impose a price ceiling of $5. It's going to be right here, just barely above it. And we'll call this our price ceiling. And it's going to be right at $5. Because they're so close, I'm going to write it in orange. So now we want to ask the question, is this a binding price ceiling or not? And the way to remember is to remember to compare the price ceiling to your equilibrium. If this is our equilibrium here, is the ceiling above equilibrium? If so, it's not going to be binding, right? Remember, we want the ceiling to be above, and so if the ceiling is high, we're fine. The other way to think of it is if the government says, hey, prices can't go above $5, but prices are stuck at $4.94, it's not going to have an effect on the market unless this equilibrium price goes up above that ceiling. So this would be considered a non-binding price ceiling, right? It's not going to have an effect on the market. It's not going to alter the way consumers or producers behave. And that's because both consumers and producers are already happy paying $4.94, and so this limit of $5 isn't going to entertain them. But what if we play around some more? What if instead the binding price ceiling is set at $4? a binding price ceiling of $4 is going to be binding. And that's because now our price ceiling is below equilibrium. We are above the ceiling. That's bad news. That is going to disturb the market. We are going to see that producers do not want to sell gas, so our quantity supplied is going to be less than our quantity demanded. And that's going to mean we're going to expect to see, in this case, a shortage, right? We're going to see not enough gas being bought and sold on the market. So that's going to be our shortage right there. And if you want to put numbers in, you can. But we're going to see a couple of things happen in this. When we have a binding price ceiling, what we're going to see is producers are going to reduce the quantity they sell or the quantity supplied. We are going to see consumers are going to increase the quantity demanded because sellers don't want to sell as much at this low price and buyers want to buy more. That's going to lead to a shortage, maybe rationing. At the very least, it's going to lead to long lines. And you can think about places where, now that gas prices are pretty high, places where gas prices are high, gas stations where it's expensive versus gas stations where it's cheap. When the price is lower than the market price, when the price is sort of below market, what is it like at that gas station? Is it easy to get gas or do you have to wait in line? So those long lines can be an example of rationing, right? The idea there is that maybe the price is lower, but you face a higher opportunity cost of your time associated with waiting in line for that higher gas or for that lower gas price. So those are going to be some of the unintended consequences that we're going to expect to see when we have a price ceiling imposed. Okay? Okay, so that took a little longer than I thought. That movie ended up being a little bit long, but look at all the cool colors on our note sheet. So hopefully that helps explain some things and helps you have a better understanding of how to calculate total welfare, consumer surplus, producer surplus, deadweight loss, tax revenue, how to evaluate the efficiency of a tax, efficiency, success, fairness of the tax, who do we want the burden to be placed on, those kinds of questions. And then also looking at price ceilings and price floors. Remember, for a price ceiling, it's not going to be binding if it's above us, but if it's below that equilibrium, that's when it's going to start to have an effect. The floor is the opposite. If the floor is below equilibrium, that's non-binding, that's normal. But when the floor gets too high, when it's above equilibrium, that's when we have a problem. Hopefully that makes sense. If not, let me know what questions you have, and I'll see you next time. Thanks so much.